All right, welcome to Mocha. By the end of this lesson, you should be able to verify a function's behavior with, wait for it, Mocha. So let's talk about what Mocha is just a little bit first. So Mocha is a testing framework. What it does is it defines a syntax for us to define and organize tests. It does not actually give us a way to write the tests themselves. So those are called assertions. So it's not assertions. If we were doing Node, there's a built-in one to Node called assert. And by assertion library, I just mean it checks whether two things are the same. Checks whether this thing is more than this thing. Checks whether the keys of these things match. Those are called assertion libraries. Checks that this promise will resolve to this value or whatever. Mocha is not that. Mocha is a way of organizing all of those things. Mocha is the green check marks and the red X's, but it's not the things that generate the green check marks or the red X's. There's a really popular tool that does those things called Chai. We'll say it's frequently paired with Chai. I'll also say that Mocha is simple. We'll see damn near like the entire Mocha library, like in these 35 minutes or whatever. There's just not that much to it. Since all it is organizing assertions. Assertions also not that complicated. There's just not a ton to them. The thing that's difficult is what to test. Writing a test, just not that hard. Figuring out how to test something meaningful that actually helps you write your apps better, that is a journey. So a basic Mocha thing is comprised of describes, and so we'll say what we're testing. And then that takes a function. Inside of the describes, we have these it blocks. And we say what it should do. And it's pretty, and then that takes a function. And then the assertion goes here. And it's pretty common to have multiple its per describe. And then a couple other things worth noting. You can nest describes. Can't nest its, but you can nest describes. There's a synonym for describe called context. Does the exact same thing, but sometimes it reads a little bit better. So I might, for example, say something like describe some function, and then I might say context user is logged in, and then I might have a variety of assertions about its behavior, and then I might do another context for not logged in. I might have a different set of assertions about those. That's probably 80% of unit tests kind of look like that. One other relevant piece. There's a helper function that we can use on describes called before each. So if there's some setup that needs to be done before we can really do the assertion, it goes in the before. So if I put a before each here, for every single one of these, it's going to do some kind of setup code. If I put it inside here, it's only going to do it for these three. If I put it here, it's going to do it for these three. Cool. I just told you basically the entire Mocha API. Questions? Yeah.
Can you describe unit testing?
Oh, yeah, absolutely. So when you talk about different kinds of tests, people typically talk about it in terms of a pyramid with a variety of different levels, but 3 is kind of common. So down here we have unit. Here we have integration. And up here we have, goes by a few names. There are subtle differences between them, but not assertion. Acceptance, it's kind of like my preferred term. Or UI tests, which are technically more popular. So it's a pyramid because we tend to have more of these than these than these. Any guesses why? I might have more unit tests than UI tests.
Units make up integration, make up the UI?
Yeah, it's a little bit of that.
Something like that?
They do kind of feed into each other. They're not testing 3 different things. They're testing the same thing from different perspectives. So that's one reason. There's another reason.
For better feedback?
Yeah, that's also part of it. But it's why those give you different kinds of feedback. Speed. These are slow as fuck. These are crazy fast. So when you did learn and you got all the green check marks, those are unit tests. And we go super fast. So we can have a lot of those really cheaply. A UI test fires up a browser, navigates to something, simulates clicks on the page, like that kind of thing. That's slow. That's super slow. And so it's also how the user perceives your app, though. So ultimately, this is the only one that matters. If you could represent your entire application's test as UI tests, do it that way. But you can't because your test suite would take 4 days to run. So we say that we have a ton of unit tests, a combination of unit tests. All right, well, this works by itself. Does it work with this other thing? We call that an integration test. You're just multiple units. And then something that is at some level simulating how a user would use the system. We'll call that an acceptance test. The term acceptance test is an agile term. That means are we ready to accept that this feature is done? So at the very beginning, when you're conceiving of a feature, you write all the things that would let you know you're done, and then write those as automated acceptance tests. When all those turn green, your feature's done. So this goes to that agile idea of well, we're not working in phases. We're not even working in the same phase over and over again, an iterative way. You wrote your test first, and then you implemented it and used the feedback from that. There wasn't a testing phase. You were never not in the testing phase. The automated tests kind of help with that. Other questions about, one more thing. When I say unit can be a function. Could be like a class. Could be a method inside of a class. Something kind of atomic, though, is what we're going for with that. Not composed of too many other things. We'll say those are a unit, and so if we test a function, or if we test a class, or we test methods in classes, any of that stuff, we call those unit tests. Other questions about types of tests? Yeah.
When you look at like the testing and stuff that's in Learn, like a simple unit test, it says like, call this function, it should return this.
That, like, if you're testing functions, that's 99% of them.
How different does an integration look? Is it just multiple functions getting called at the same time?
So what starts to happen as you move up the pyramid is you require more and more setup. If you wrote pure functions, I just give you these values and you should give me this thing back. Very deterministic. As you move up, you get more into like, well, is the user logged in? Are we currently in an error state?
Okay.
Like that sort of stuff.
Okay.
And so you get a little bit more of it with this. It's like, if this unit is in this state, does this unit behave correctly? So that ends up requiring a little bit more setup code.
Okay.
I'll also say, you can use Mocha for all three of these. The things that happen inside those it blocks can look substantially different, but Mocha just helps us organize the tests. It doesn't care that it's unit or whatever. Now in practice, you tend to see Mocha or something like it for these two. And by something like it, Jest is super popular right now. Jest is kind of like Mocha with all of the things that people generally have to hack into Mocha to make it like work the way they want. You'll commonly see Mocha for these, and you'll see a tool called Cypress for this, or Selenium. Selenium is what people did for this for like the last few decades. It sucks though. Cypress is way more popular right now. But Cypress is just Mocha with some extra shit. Still describe blocks, still it blocks, it all looks the same. And even more broadly, outside of JavaScript, there's like 2, maybe 3 different like common formats for organizing tests that go something kind of like this, or there's another one called XUnit that's also kind of popular. But like RSpec, the one that all your Learn tests are written in, it's that style. If you look at any of those RSpec tests, it will look very familiar. Other questions?
What is
Yeah.
RSpec?
RSpec is like just like Mocha. In fact, you could say that Mocha is RSpec written in JavaScript, and that'd be pretty accurate.
Okay.
Cool. Anything else? Cool. So let's do some setup for this. I'm going to recommend not following along with me because I'm going to make some mistakes in this. So I'll stop when I get it working and we can all catch up together. So I'm going to say this is browser Mocha, and I need a couple things. I need an index.html file because I need that to load in my JavaScript file. I can't test the JavaScript file independently. That's the distinction. So I'll say touch index.html and app.js. And then I'm going to make a directory called test, and I am going to I'm going to put something called spec.js in there. And I'm also going to put one called runner.html in there. So when I do this correctly, I'll have my app, which brings in this app.js file. And then I'm also going to have this HTML file that will have my tests and also pull this in so that I can get its functions and like call tests on those. And then this HTML page will show me the like checks and X's. So if I go to the Mocha docs, it should walk me through how to do that. Browser, there we go. Mocha runs in the browser. All right, so I think this is the one that I want to use for my test runner. Yeah. Cool. So if I go to runner.html and paste in that thing from their site, pulls in their CSS, pulls in Mocha and Chai. This is where all the tests end up showing up. And this is the setup for the tests. And then these are the actual like tests themselves. So I'm gonna say that I called mine spec.js. Okay, that should be, that should get it set up in the browser. So then when I run this file, I serve this file up, it should do all the magic for me. All right, and then here's some examples of how it can be used. You can do notification support. Okay, and then that's the node setup. All right, so I'm gonna do something kind of similar with this. This will be like my actual app. Keep Video Game Arcade. And I'll say Video Game Arcade. And then app.js. Okay. So I'll say, I'll serve it out of there. And then I'm going to run the tests here. So over here, I'll say light server. Oh, and actually, I can run it with tests runner.html. Test runner.html. Cool. And so this, instead of the command line, that's where like the X's and check marks will go. And then in our spec.js, if I do describe smoke test, it should pass. And then I'm going to do chai.assert that true is true. I think that's how it works. Got some kind of issue there. I think I'm going to just turn off that detect leaks thing. Okay, cool. So we've got that. Now, here's where the cool shit happens. If I do app.js and I make a function here called sum that takes in number 1 and number 2, and I include those include that in the runner. So I say app.js. Now in my spec, now I can write a test for that. I can say something like sum should add 2 numbers, and I can assert that sum 1 and 2 should give me 3, and that should fail. Oops, something didn't like. Oop. Chai.assert equal. Chai.equal. No, you actually intentionally don't want to write the function yet. API. Oh, I see. I think it's because I did it this way. Expect sum 1, 2, 2 equal 3. Does that work? Chai.expect. Chia. There we go, perfect. So I said chai.expect that function call to equal 3. I'm gonna make it a little bit more readable. Just say sum or total. Cool, and it fails because it's expecting undefined to equal 3. If I go back over to my app, I can make it pass by just returning 3, turns green. So I can make sure that I'm not doing something like that by saying it adds 1 and 2 and saying it adds 2 and 2. And now to get them both to turn green, I have to actually do something like that. Cool. That's testing. So let's go back over the things that I did and then give you guys a chance to catch up. So I have an index.html. Really all it's doing is pulling this in. This is our regular app, right? It has this app.js file. This could be anything, any kind of function. Additionally, we have this runner, which I pulled almost all this off of the Mocha website. I'm bringing in that app.js file. I deleted the check global leaks thing. Otherwise, I think that. Oh, and then I made the test match this file that I made, which has the tests in it. So the total tree for this looks like that. In the browser, I'm serving up my video game app, and then /test/runner.html is running my tests.
You have 2 lightsabers on there?
I don't actually. Just the one. But since this whole test folder is inside of the thing that I'm serving, I can also see those HTML pages. Questions so far? Cool, your turn. See if you can catch up with me.
Okay. Fine. Okay, well, you're pretty close. That's a fine start. Okay. Let's see if we can get that far, so you can at least have something to look at. So put something in those schools. Like smoke test. And then if it works. That'll, you'll need to hit after the test score. Yeah. And so we'll know that all this was wired up correctly. Nothing. It's just showing that like Mocha was wired up correctly. And so we get a green check mark if everything was wired. That's what a smoke test is. If you plug it into the wall and it doesn't explode, that's how we'll know we're done. You might not have yet. So let's take it, so save this and let's. Okay, let me take a look at learner.html. Cool. So go to mochajs.org. There's a H after this. Now scroll down. Browser support. Okay, just copy and paste all this. Now, get rid of check these. Perfect. And then these three like test things there, just we're gonna pick one of them. You say spec.js. Gotcha. Okay. Now with only this, save spec.js. We should be able to run this. So if you run light server in this folder. Yeah. And now go to /test /learner.html. Cool, your smoke test works. So now all you need to do is whatever app you would normally have, your regular index.html, regular app.js, you go to runner.html. As long as that app.js file is included above the spec.js file, you can call any of the functions from that and write tests on those. So copy that script line and make that, copy that, upload it.
Is there, do you have the
Yeah,
app.js as your index?
It would be ./app.js.
No, I know, like go to your index, okay, and then go to your runner.html.
Cool. Now, every function you write in app.js, that's available in spec.js.
But,
So we can write those tests.
okay, but I don't understand that word. Like, let's say I go in, app.js.
Okay. copy that whole thing. And the thing we're describing is add numbers.
Okay.
So change that. Yep.
In my, as a description or like an actual reference to the actual function?
It's just a description. All these strings are, they're just for you.
Okay.
And so you can say like, it adds. Cool. So now, that add number function, that's like visible in here. So we could say like, sum equals add numbers 1 and 2 or whatever. Cool. And now, use the same syntax, but expect sum to equal 3.
Okay.
So hit enter. They have the same kind of format.
Oh.
Nope, just like this. Just like child expect. And you wanna expect sum. Yep. To equal 3.
Okay. Oh.
And since you didn't implement the function, you should get a failing test. So you go back, save all these, go back over to the browser. Cool, expect undefined equal 3. Undefined is one of the functions now, so that makes sense. So if you go back over to app.js and actually implement the function, you should get a change.
Okay. That kind of.
That's it. Ta-da. But now, as you're refactoring stuff, as you're changing stuff, as you're doing something that's more complicated, adding two numbers together, you can make sure that you didn't change the behavior of the function. That's still working the way that it originally did. And just like how the learn tests almost kind of feel like they're guiding you down the thing. Well, if you know what the end result is supposed to look like, you can write tests that are just all the end results. Now you got your own personal learn.
I understand. I try to figure out.
Okay, starting place. And like I said, there's 80% of the book is syntax. There's not much to this shit. Learning how to test something valuable, that's something we're gonna be working on for a while. But syntax is the first step. All right, who else needs help? Okay. Okay. We need to change these. So we'll have one of them and make it that spec.js file. Yes. Oh, yeah, move that down, because, this runs top to bottom, so Mocha wasn't even set up, but you were right.
Yeah, there's like way more complicated tests, I'm sure. I don't know.
Yep, that works. And then, before the runner, before the dot
Oh,
run.
yeah, I just was telling you.
Okay, these test.array, test.object, test.xdr.
Yeah.
That's what we're replacing, so get rid of all three of those.
Get rid of all three.
Yeah.
I'm going by myself, but like I have both like all weekend.
Cool, save it.
Sweet.
Cool.
Thanks.
Yeah.
Who else needs help?
I know, me too, I was like,
Good?
that's why I kinda wanted to.
Looks good. Let me see your learn.
I'm like telling me why.
Okay.
Yeah, I'm going in the room. Oh, I don't need to get out of it. What?
Okay, so this,
And
do you know
he's,
what a smoke
like,
test is?
super nice about it.
Kinda. All right, everybody, smoke test. So this is a common testing term. Smoke test is, all right, I just designed this awesome computer. Before I figure out whether or not the computer does the thing that I want it to do, did it catch on fire? That's a smoke test.
So it goes back to early electronics. When you make a toaster or a microwave or whatever, that's test number one. Did it catch on fire when you plugged it in? So our smoke test is just making sure that we wired up our test runner correctly. It doesn't actually test anything meaningful. It's not supposed to. All right. So you have this app.js file. Go over to runner.html. So right above that, we want to include the app.js file. It's going to be .app.js. Slash. Cool. Now, every function that you write in app.js, now that's visible inside spec.js. So you can call functions and write little assertions from there. Good shot. Cool. What else? Yeah.
Can you write parts for individual parts of your function? So if you have a function that does like tons of stuff, can you write it that says it like it does this and this and this, or just
Nope.
the final thing?
Just the final thing, which is yet another reason to write tiny fucking functions. Because when we write these big monster functions, you can't test part of it, only test the entire thing. Now check this out. This is kind of interesting. So you might imagine like, there's a lot of functions that we do like this. We pass something in, we should get an output. All the tests generally kind of look like that. What if we had something that did have side effects in it? Check this shit out. So I could say, maybe I make one called increment. So I do let count equal 0. And write a function called increment. And all it does is increment count. So you could also write a test that was something like describe increment. Well, if I'm describing increment, it should increment a count by 1. So then I can write an assertion in here that asserts that count equals 0, and then I call increment, and then I expect count to equal 1. And my sum is broken. Oh, it says I deleted it. That'll do it. So now I got a green check mark. Why can I see count in here? Count isn't in this file.
You require it in app.js.
And it's visible there. The way browser, like pure browser JavaScript works, it's top to bottom. It pulls in all this chai code. It pulls in all this Mocha code. All the app.js code can see that stuff. Then this mocha.setup, I can do that because Mocha was already brought in. Then it brings in the spec.js file. It just runs top to bottom. It's all one scope, even though it's different files. The global scope on all those files is exactly the same. That's why I can see the function. That's why I can see the variables, see all that shit.
And it's also able to set those variables from the test?
Yes. So, and that's important because let's say I want to make sure that I can call it twice. By 2 if called twice. Well, the problem is if I do that, can anybody guess what the problem is going to be? It's not starting over. Expected 1 to equal 0. Oh, because it already incremented it once. I didn't reset anything. So that's where before eaches come in. So I say before each one of these, count should equal 0. And now they're all green. So any kind of like shared setup, the state of the application that is needed for these tests to work, that happens in a before each. Think back to the DOM calculator. This is a really good reason to have the parts of your DOM calculator that do calculations and the parts of the app that display the results of calculations be two different things. You can do a DOM assertion with these things. It's gnarly though. And also kind of not what unit tests are. That's moving up into like UI territory, right? Or a minimum integration. But I can check that a calculation was done correctly, completely separately from whether or not it was displayed correctly, if they're two different functions. Yeah. Oh, let me see. Which one was returning pending? Increment. Should increment count by 1 back over here.
I'm hungry.
Looks pretty good. Go back over there and just refresh. Back over here. All right, let's check on that together after this. One other thing I want to show you. This is really handy if you want to use this on a project or something. Part of how we want to use these tools is we want to start with the end in mind. How will I know that I'm done with this function, with this app, with whatever? And so before you start writing any code, you write all the things that would let you know you're done. And if you're like, I don't know what those should be, it's tricky, but keep in mind, what would you be console logging? What would show up in the console log that you go, cool, it works. Just make that a test. And now it's like console logging for you, except faster, and you don't have to type it out every time. But we write all these things out, and we go, all right, but I'm not ready to implement all of them, and I don't want them to all be failing. You just put an X in front of the it, and it shows those as pending tests. And then you can uncheck them. So if you ever need to bypass a test, just put an X in front of it. Cool. Other questions about Mocha? Only for JavaScript. But basically every language has some kind of test runner that's sort of shaped like this. Other questions? This is most of the syntax, Amoka. So if you're thinking, well, wait a minute, I can't write great tests yet. Yeah, it's more complicated than that. But a lot of that stuff is with Chai. If this is the only thing you know how to do in Chai, though, like, that's all right. Just verifying that things are equal to each other. The other things that you can do are like verify that something contains text. You can verify that something's greater than or equal to something. Ultimately, though, they're all kind of just this. Note that that won't work with objects. So if I did a chai.expect object to equal object, that's going to fail. Why? It's like the first problem you're going to run into in testing. Anybody know why? Different instances. It's checking to see if they're literally the same instance. So if I did const sum object, and compared those, that'll pass. But since they're different instances, those don't match. If I want to check that the values in those are correct, deep equal. Oop. Fuck. Might be EQL. Yeah, there you go. EQL instead of equal will compare the values of objects. Everybody else calls that a deep equal. Chai. Other questions? RSpec. And RSpec is the same format as all of this. If we look at like any Learn Lab, like nope, it's JavaScript. There we go. All right, so here's RSpec. These are like, this is the one of the first Learn Labs. Describe before it, expect to equal, same shit. So before every one of these, we make a song, then we just make a bunch of assertions about that song. Slightly different syntax, but not really. Since Ruby doesn't have standalone functions, you pass these blocks instead. Cool. Anything else?
Should we make a test for every single?
No. And again, what to test? That's a hard one. My favorite book on the topic, and we can do another lesson on this sometimes if you're interested. My favorite book on the topic is called Developer Testing by some Russian guy, Alexander Tarlander. This book, I think, is the best book on testing I've ever read. But it's long because writing meaningful tests is hard. Because you don't want to test absolutely everything you could possibly test, because then as soon as you change anything, all your tests fall apart. That's kind of the opposite of what tests are supposed to do for you. The purpose of testing is to give you confidence that my code works the way that I think it does. You know how like before a project, you'll change something and then go, I didn't break anything, right? And then you do this, and you do this, and you do this, and you create an account, can I log in, can I do this, can I do this, can I do this? Testing is just to automate that part of it. So it gives you confidence that it works the way you think it does, so that when you change it, you know whether or not you broke it. That's kind of it. When I'm doing that refactoring I was doing with DOM Calculator, how every time I had to go back to the fucking calculator and, all right, do the calculations work? There could have been plenty of things in there that I missed because I didn't want to do all 8 things that might give me confidence the calculator still works. The very important part of refactoring is like, I changed the code. Did I break it too? If I just have those little green check marks over there and they stay green as I'm changing, I know I didn't break it. That's what testing's for. And you can imagine that like that's useful when it's just me refactoring a DOM calculator kind of thing. Imagine 100 developers, 1,000, 10,000 developers on one code base. Can I delete this? I don't know, somebody else might be using it. But I need to make a change to it. Call it my version of this function, and now you have your whole code base littered with that shit because everybody's too afraid to delete things because we don't know. It's too much at this point for anyone to check everything. So I just leave it in there, and that's how code bases die. It's called tech bankruptcy, when it's faster to just start over again than it is to make any changes. Cool, have a good lunch.